So, this is some of the properties of the gamma distribution, and gamma distribution has this kind of different values of the parameter. You can find many form in this form, and also this cumulative distribution function looks like this, but most you can see that it is a unimodal also. Mode means it has maximum value of the density function, it is one maximum value. It looks like sometimes either it is only decreasing or it is increasing then decreasing. So, that is why it will be on one maximum, local maximum, and also that is the global maximum also. Now, let us discuss some applications of the gamma distribution. So, there are many applications of the gamma distribution. The gamma distribution is often concerned with the amount of time until some specific event occurs. So, this is like a lifetime of a survival analysis, lifetime data analysis. We usually use the gamma distribution. The amount of time beginning now until an earthquake occurs, the length in minutes of long distance business telephone times calls, and the amount of time in months or a car battery talash, the time between two customer come at a computer center. So, whenever you are modeling like some time variable or lifetime, positive, it is a positive random variable, and it is also unimodal. So, in that case we can use a gamma distribution. So, let us do one example using a gamma distribution, a numerical example, so that we can apply a gamma distribution. The daily consumption milk in a in a city. So, there may be a typo error. In a city, the daily consumption of a milk in a city is approximately distributed as a gamma variate with parameter alpha is equal to 2 and lambda equal to 1 by 10,000. The city has a daily stock of 10,000 gallons. What is the probability that the stock is insufficient on a particular day? So, here it is mentioned that X has a gamma distribution, parameter alpha is equal to 2 and lambda is equal to 1 by 10,000. So, then the density function we already know, f of x can be this is nothing but lambda to the power alpha x to the power alpha minus 1 e to the power of minus lambda x by gamma alpha whenever x is greater than 0, less than infinity, 0 otherwise. This is the density function. In particular, for this example, alpha is given 2 and lambda is given 1 by 10,000. Now, it is asked that the city has a daily stock 10,000 gallons. What is the probability that the stock is insufficient on a particular day? So, when the stock will be insufficient because the city has a daily stock 10,000. So, already, so if this it is a x actually variable consumption. So, when if the milk consumption of a particular day is less than 10,000, then it will be sufficient, but whenever it is exceed and some a particular day it exceed milk consumption exceed 10,000, then it will be insufficient. So, that means it is asked that the probability that x will be greater than 10,000. So, we will find out the probability. So, this question asks that what is the probability x greater than 10,000. So, this is we have to find. So, x greater than 10,000 is nothing but it will be integration 10,000 to infinity f(x) dx, where f(x) is the gamma probability density function. This is the probability we have to find out. So, then let us do it. So, this is nothing but, so integration probability that x greater than 10,000, it is nothing but integration 10,000 to infinity f(x) dx, which is equal to integration 10,000 to infinity lambda to the power alpha x to the power alpha minus 1 e to the power of minus lambda x. So, let us put those values. So, now let us, alpha is already given, lambda also, lambda is 1 by 10,000 whole to the power lambda to the power alpha is 2 and e to the power x to the power alpha minus 1, this is 2 minus 1, e to the power of minus lambda x. So, x by 10,000, then dx by gamma 2, gamma alpha. So, this is the formula of the f x x gamma alpha. So, that we have just used here, f x x is this. So, we can write this so that there will not be any mistake. Integration 0 to infinity lambda to the power alpha x to the power alpha minus 1 e to the power of minus lambda x by gamma alpha dx. So, here we put alpha is equal to 2 and lambda equal to 10,000. So, that lambda is 1 by 10,000 whole square x to the power 2 minus 1 e to the power of minus x by 10,000 by gamma 2 dx. So, now we have to do this integration. So, let us see that, because gamma 2 is nothing but we know that it is integer. So, gamma L plus 1 is L factorial. So, this is 1 factorial, this is 1. So, that is this is coming out as a 1. So, now this is a constant 1 by 10,000 whole square, and then we have to do this integration 10,000 to infinity x to the power 2 minus 1 is x e to the power of minus x by 10,000 dx. So, that integration we have to do. So, suppose if we can have some simplification, let us do that. So, suppose let us put z is equal to x by 10,000. So, then x is equal to 10,000 into z. So, dx is equal to 10,000 dz. So, x whenever x is limit is 10,000, z is 1. So, this is nothing but 1 by 10,000 whole square. So, limit whenever x is 10,000 1, and whenever x goes to infinity, then z goes to also infinity, and then it is x is 10,000 into z, x is 10,000 into z, then e to the power of minus x by 10,000 is z, dx is nothing but 10,000 into dz. So, then this 10,000 square it is cancelled. So, this is nothing but 1 to infinity z e to the power of minus z dz. So, that we would want to find. So, basically it is very simplified form we have got. So, this is nothing but hence probability that x is greater than 10,000, it is nothing but what we found, it is 1 to infinity z, 1 to infinity z e to the power of minus z e to the power of minus z dz. So, then because okay. So, now we can use we can use integration by parts to do it. So, let us take it is, so this is nothing but z, then integration is minus of z. So, then this is the integration of these things 1 to infinity. So, then minus then 1 to infinity derivative of z is 1 and integration of e to the power of minus z minus of that, then this will be dz. So, then if you put this limit, so whenever z goes to infinity, this goes to 0, but this limit of z e to the power of minus z at z goes to infinity, this will be 0. We can use L'Hospital law to find the limit. So, it will be 0, and now at 1 it is nothing but 1 e to the power of minus 1. So, this is nothing but e to the power of minus 1, this is another 1 is there and we are subtracting that. So, that is why minus and minus plus e to the power of minus 1, and now it will be minus of 1 to infinity this e to the power of minus z. So, this is plus 1 to infinity e to the power of minus z dz. So, this is e to the power of minus 1, again this plus minus or e to the power of minus z, and then limit 1 to infinity. So, similarly it will be z goes to infinity, this is 0 and e to the power of minus 1, this is minus and minus plus. So, it is e to the power of minus 1 plus e to the power of minus 1, it is 2 into e to the power of minus 1. So, basically this probability is 2 by E. So, this is the probability that in a particular day if the mean consumption is more than 10,000 gallon. So, that is the probability that the stock is insufficient on a particular day. So, this is one numerical example we discussed of gamma distribution. So, this is one of the important distribution. Now, we will discuss some other important distributions. So, one of the important distribution is very useful, that is called normal distribution. A random variable x is called a normal or Gaussian random variable with parameter mu and sigma square if its probability density function is given by this. So, f of x x equal to 1 by root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square. So, it is actually first introduced by Gauss. So, he is a scientist, mathematician. So, for a particular experiment he found it is very useful, and then he introduced it. It looks very complicated, but in the nature most of the data follows normal distribution, and also if it does not follow also by some transformation, we can most of the time we see that whenever data is large, it can be used, you can be considered as a normally distributed random variable. So, let us discuss this normal distribution and also we will discuss its applications. So, a random variable x is said to follow normal distribution with parameter. So, there are two parameters, one is mu. So, this is belongs to real number, it may be positive and negative also, any real number, and another parameter is sigma square. So, this is a square of a real number, it is always greater than 0. If the probability density function of x is given by f of x, and this is nothing but 1 by root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square. So, it is actually defined for whole real line, minus infinity to plus infinity. So, there is no anything else to write, like other density function we wrote it is equal to 0 otherwise like that, but it is defined whole real line. Now, this mu and sigma, it has some these are some parameter, and also it measures something, like if you consider mu is equal to 0. So, this density looks like mu is 0 and suppose variance sigma square is 1. So, then this curve looks like it is actually it will be symmetric around 0, it looks like a mirror image. Left side if you see, then right side it will be very similar to the so this axis, and here it will be the mode also, it is the. Now, mu will see that it will be nothing but the mean of this random variable, and sigma square will see that it is the variance of this random variable. So, that we will see that. First we will check. So, now if you change the mean, so then suppose mu is equal to here mu is equal to 5 suppose, then this will be looks like this. So, actually it is not correctly drawn. So, this so it will be symmetric and it will be the maximum value and still have symmetric around this line. So, this is the suppose this is the mu is equal to 5 and some variance. So, if you change the variance, so actually this parameter, so like it will be sigma square is suppose greater than 0, then greater than 1, then it will be more flat, and if sigma square is less than 1, so that means it will be more steep. So, because the density function actually it will be area will be under this curve will be equal to 1. So, the variability less, so this height will increase, and whenever variable large, then it will be flat, height will be decreased. So, now we want to check whether this is a probability density function, how it is. So, it is always greater than equal to 0 e to the power of something square. So, it is always greater than equal to 0, this is also a constant. Now, we want to see that how it is a probability density function. So, probability density function, it is always greater than equal to 0. So, we have to check whether minus infinity to plus infinity f x s dx should be equal to 1 or not. So, this is equal to minus infinity to plus infinity 1 by root 2 pi sigma e to the power of minus x minus mu whole square by 2 sigma square dx. Now, how we will do this integration? Now, you can see that we use this some of the properties of gamma function also we will use. Now, it is a even it is okay. No, we will take some kind of transformation first. Let us take this transformation z is equal to x minus mu by sigma. So, then this x can be written as sigma z plus mu. So, then dx is equal to sigma dz, and the limit does not change because x goes to in minus infinity, z goes to also minus infinity, x goes to plus infinity, z also plus infinity. So, this is nothing but minus infinity to plus infinity 1 by root 2 pi sigma e to the power of x minus mu by sigma square. So, x minus mu by sigma, so e to the power of minus z square by 2, and then it is dx is equal to sigma dz. So, this sigma this is cancelled. So, it is root 1 by root 2 pi. So, e to the power of minus z square by 2. So, this is nothing but 1 by root 2 pi minus infinity to plus infinity e to the power of minus z square by 2 dz. Now, it is a even function. So, you know that what is even function. Suppose f is a R to R is a function. So, then f is called a even function if f of minus x is equal to f of x, and it is a odd function if f of minus x is equal to minus of f of x. Now, here we will see that by even function, it is a even function because if you take z minus z, it does not change, it is same as the this function f of e to the power of minus z square by 2. Now, for even function also we know these things that if is a even function, then minus infinity to plus infinity f x dx can be written as 2 into 0 to infinity f x dx, and if it is a odd function, if f is even function. So, then if f is odd function, then if it is even function, then we can write like this. If it is odd, then we can write minus infinity to plus infinity f x dx, this is equal to 0. So, you can check all these things, this is part of the mathematics courses you have learned somewhere. So, then if it is even function, so we can write that 1 by root 2 pi 2 into 0 to infinity e to the power of minus z square by 2 dz. Now, we will find out what is the value we will get. So, because it is nothing but 2 by root 2. So, this is nothing but root 2 by pi at 0 to infinity e to the power of minus z square by 2 dz. Now, we will find out what will be the values of this e to the power of minus z square by 2. Now, 0 to infinity e to the power of minus z square by 2 dz, this is equal to, we will take some transformation. Suppose because we want a form of the gamma function. So, gamma function is gamma alpha is defined by 0 to infinity e to the power of minus x to the power alpha minus 1 dx. This is gamma. So, this we want to write this in this form, so that we can use this gamma function. Now, all this other result we know that gamma alpha plus 1 is equal to alpha gamma alpha. If it is a integer, L is some natural number, then gamma L plus 1 is equal to L factorial, and also gamma half is equal to root pi. All those things we have discussed in our previous lectures. Now, here we will use this information. Now, to have this gamma function, it is e to the power of minus x form is there. So, that is why we will take transformation. So, e to the power of minus z square by 2, we will take t is equal to z square by 2. So, then z square is equal to 2t. So, because z here 0 to infinity positive, so that is why z is equal to root over of 2t, and then if you take the what will be the dz, dz is equal to root 2 is there, 1 by root 2, 1 by 2 root t, 1 by root 2t. So, because derivative will be 1 by 2 minus 1, yeah, then this is nothing but dt. So, then this is equal to what we will get, and also what will be the limit. So, you can see that this limit whenever z goes to 0, then t goes to 0, and whenever z goes to infinity, t goes to infinity. So, that is why the limit does not say 0 to infinity e to the power of minus z square by 2 e to the power of minus t, and then this okay, we have I just take a then a mistake maybe. So, I have to find the no, it is fine z, okay, this is nothing but dz. So, dz, so root 2, this is root 2 by 2, root 2 by 2, then 1 by root t to the power 1 by then this root 2 and then dt, this is the things. So, this is just simplify this 1 by this is 1 root 2 by 2, this is 1 by root 2, 1 by root 2, 0 to infinity t to the power minus half, t to the power minus half e to the power of minus t dt. So, this is looks like same, just you have to find what will be the power, you have to write as a alpha minus 1. So, this is 1 by root 2 0 to infinity t to the power minus half, we can write half minus 1 e to the power of minus t dt. So, then it looks like very same as this formula of gamma. So, it is gamma half 1 by root 2 gamma half. So, gamma half is we already mentioned this, we did not prove, but it is part of the mathematics. So, integral calculus there you have already learned it. So, that half gamma half equal to root pi. So, this is root pi by root 2. So, now we will replace this value here root pi by root 2, here you can see that this is root 2 by root pi and then this is nothing but root pi by root 2, this is nothing but so 1. So, that is why this is a probability density function. Now, we will find out what will be the mean and variance of the random variable. Some of the result we can see here. So, now if you can see that suppose x is a normally distributed random variable, x is a normally distributed random variable and with mean mu and variance sigma square. So, then we represent this like this, x has a normal distribution random variable mu and sigma square. Now, if mu is equal to 0 and sigma square is equal to 1 and x has normal 0 1. So, it is known as standard normal random variable, standard normal it is called as standard normal variate. So, now if you want to find the cumulative distribution function of a random normal distribution function, so then you can see that f of x is equal to probability that x less than equal to x. So, then it is nothing but minus infinity to x f x t dt. So, for x is a any normal distribution, suppose x is normal in general mu sigma square, then we are finding the cumulative distribution function. This is nothing but minus infinity to x 1 by root 2 pi sigma e to the power of x minus mu whole square by 2 sigma square dt. So, basically it is actually t. So, this is t minus mu whole square by sigma square t minus, so t minus mu whole square by 2 sigma square dt. Now, whatever the value mu and sigma square, this integral is the improper integral and it is intractable. So, you cannot find a particular form of the integration and you find the limit, then you cannot find the value very easily. So, one of the method is that numerically you have to compute it. So, numerical means you have to use some of the computational technique and it is very time consuming. So, for standard normal variate, whenever mu is equal to 0 and sigma is equal to 1, sigma square is equal to 1, this probability is given in a table. So, that we will discuss. So, then we can use some kind of transformation. So, this transformation for finding the probability of any standard normal variate. So, that transformation is like that. So, if x is a normal mu sigma square, then z is equal to, if you take this transformation, subtract this mu and divide by the square of sigma square by sigma, it will have a normal 0 1, it will have a normal 0 1. So, this kind of transformation then useful, because then if you want to find the cumulative distribution function of this, you then suppose probability that x less than equal to x you want to find. So, then which is equal to probability that x minus mu by sigma is less than equal to here x minus mu by sigma. So, this is nothing but the z. So, probability that z less than equal to x minus mu by sigma. So, then because you know the probability with respect to z, so then you can find the probability from the table. So, that again we will discuss this in details how we can use this. So, these properties we will discuss in general. Let us you find the mean of a normal distribution.